Okay, next chapter, chapter 8, resource management and monitoring. We're going to look at these 4 items, starting with virtual CPU and memory concepts, which we've kind of been talking about and kind of using them, but this dives a little further into how they function. So if you have noticed, we're dealing with a lot of different layers, and the big three are the application, the operating system, and ESXi, and how each of these can access certain information, certain resources, and how some of it is elastic for these. For example, memory, it is possible to overcommit. Uh, since virtual machines don't tend to use all of their RAM, it is possible to overcommit the memory that we physically have versus the memory that each virtual machine has, and they're able to share without crashing on each other. Any overhead would go into a swap file as needed. If a VM if a VM sees that it's not using a whole lot of memory, then it'll be taken and used somewhere else. Having solid state drives will help with cache swap so that it's really not felt by the VM at work. The VM kernel swap space is a last resort place, but it's really slow to get stuff in and out. So you really want to have some SSDs in your data center. CPUs are definitely something important to be shared among virtual machines, especially because they don't really use all the power there either as well. So a host who has like a quad core, each core itself can be shared among other virtual machines. If your physical machines, the CPU has hyperthreading, which tends, if it exists, it tends to be enabled by default. It'll allow 2 processes to run at once because a CPU can only do one thing at a time. With hyperthreading, they can do 2 things at a time. VM kernel does the job of load balancing, of looking at the CPU, seeing which ones are heavily working, which ones are not, and balance the load across all the CPUs that exist. You don't have to manage that. It is possible to set limits and reservations for our virtual machines if we put them in resource pools. So we may have a available capacity of, let's say, 32 gigabytes of RAM, but we want to for sure ensure that we have uh, 4 gigs reserved to each VM, and then we have a space where they can share. We can set all that up. You can create resource limits within the virtual machine settings. So here, for example, we have 0 megahertz reserved for this specific VM, and we have 0 megabytes of memory reserved. But we could say that this virtual machine has X amount of reserved CPU power and X amount of RAM dedicated to this VM, no matter what. In this case, everything is open to either the full limit or nothing, depending on the usage of that VM. Yeah, you got to think of the VMs as resource consumers. So VMware itself does a good job of managing that, but you can also set that up yourself. A resource pool can be a way of making a hierarchy to manage CPU and memory resources. So if we have, let's say, a 16 core CPU system with 64 gigabytes of RAM, we could make 2 resource pools to divide that in half so that these VMs can access half and these VMs can access the other half. So here you can see we can name a resource pool, something that we can understand later. How many shares we want to have, any specific reservations that we want for this pool, if it's going to be static or something we can expand later, and what the limit is. Same with memory. We can choose how much of the resources that we have are dedicated to this specific pool. And then the VMs within there will take from that pool. You can make a resource pool within a resource pool. You can isolate pools from each other. You can do access control and delegation. So you could, if users are accessing ESXi, you can give them only specifically what they can do within their pool, which is great for controlling how much resources being used per host. So here we have our main engineering pool, and it has 4,000 CPU shares with a reservation of 1,000 megahertz. That's our limit. And then the engineering test VM will take 1,000 of the 4,000, and our engineering production will take 2,000. So we have 3,000, or we're using 3,000 of the 4. We know for sure that this production system has some reserve CPU power and its maximum. In this case, we have double, we have more hosts together. And in this pool, our CPU shares are 8,000 for finance and 4,000 for CPU. And again, we can divide that out per VM. Which is great if we really want to see what's happening in these systems and be able to manage what they can use. So in this case, if we see that CPU shares in our engineering test are about 33% of the allocation, then we have a better picture of how much we're using overall. And then we can dedicate resources as needed, rather than just giving everything to everyone. Oh, looks like I jumped way out. It's all chapter 9 stuff. And I know we were somewhere around here. Aha! We can make pools that can grow as needed, just in case we underestimate and we have a burst where a VM or a set of VMs need to process more, and well, they're able to expand for that moment. When you do this kind of stuff, make sure that your physical system has the space to handle a burst if need be. You don't want to overcommit a resource pool. That will backfire. And here's an example. We have a total CPU of 10,200 megahertz. Our e-commerce pool has a specific reserve of 2.2 megahertz from the 3 that is given to this pool. We can't go past a certain point because that's how much we have, and this is not expandable. So this will have only 1,000 megahertz in place, or 1 gigahertz in place, and these 3 machines inside have to share that 1 gigahertz. Whereas this one, it is possible to expand it if it's needed. So here, even though we have 1,200 megahertz in place, if this needs more, it is okay to expand because we can, we still have some that we could use. Our 1,000 megahertz over here is still fine. This may have gone over, but we have in total the 3,000 megahertz to split. So this is able to expand as needed, and we're fine because we're still meeting our reservation, and we're not going over our total. If you want to add more VMs into a pool, make sure that it doesn't go over what you have set in the pool. Otherwise, maybe you should expand the pool before you add another VM into it. A resource pool has a summary tab and a couple other options. So you can see in this production resource pool how much they have free, how much they have used, how much memory they're using, how much memory they have, and how many VMs exist, how many of them are powered on, so on and so forth. We can monitor and see specifically which VM is using what and make any limits to the VMs as needed. We can even schedule tasks for our resource pools. A virtual application is an object within our inventory, our vCenter inventory. It's a container, really, for one or more virtual machines. And you can package them together like a multi-tiered application. So for example, a virtual application could be your domain controller, your database, your mail and web server, all in one group. And we have that, hey, this whole group will start up automatically and the VMs will start up 120 seconds from each other. So this whole thing is a VApp. They'll all work together as one unit. These can be imported and exported as OVF templates. Useful when you have a specific infrastructure set up and you need to back it up or you need to clone it out. That's where VApps come into play. And now monitoring resource use. This big rectangle in orange, that is some sound advice. Don't make casual changes to your production system. The last thing you want is to make a change to your production system that causes downtime, that just, it makes for a really bad day. Don't make any casual changes to your production system. Be thorough, be strategic, know exactly what you're doing and the result before you make any changes to your production system. You are able to monitor what's happening inside and outside the virtual machines. For example, if it's a Windows machine that's running as a VM, you have Task Manager. The Perfmon, the performance monitor with VMware tools will tell you what's happening within that virtual machine. You could also use EXS Top if you are connected to the shell, either by being in front of the box or SSH into the box. You can see exactly what each VM is doing. You have the statistics that's already available to you, where you can also see the same. These performance charts that exist already within vCenter can be handy in trying to troubleshoot, overall what's happening on a VM, or if we start seeing some anomaly traffic, we can kind of start seeing that, hey, this machine started acting funny on this day, this time. Here is the odd spike out from the usual work of this virtual machine. You have a number of options available to you to create your chart. So this is great that you have this information at your fingertips and you're able to search for it and be able to pull out information as needed. vCenter does capture information at different time intervals. So you have the fastest is 20 seconds all the way down to 1 day. It'll build out these samples. Your chart types can either be line, bar, pie, or stacked, depending on the metric that you're looking at and the best way to showcase that data. You are able to export your charts either in PNG, JPEG, or CSV. Great when you need to write a report and you need to add these charts to show any information that's relevant. So you can aggregate a number of information from different instances together, like CPU, NIC, memory. Your statistics type will depend on the information you're getting. So like the rate would be based on the usage. A delta would be from the previous interval, or absolute could be something like memory. Your roll up, well, we can't keep every 20 seconds of every day. That's going to be a whole lot of data. So data gets rolled up together into single values for historical reference. So like I said, you could put tools together. So you could get information from Task Manager and the Guest OS and then match it with the information that you're seeing in vCenter together to get more points of view as to the activities that are happening in your infrastructure. Any CPUs that are any virtual machines that are causing a lot of CPU activity, they're going to stick out. It'll be very easy to create those charts and see which virtual machine is very, very busy. Same with memory. Any virtual machine that's eating up too much memory, that will be easy to graph and show. If there's a lot of swap happening, then you know that specific VM, the host memory is getting overcommitted because it's writing to disk. Again, VMware provides you the availability to see what is happening in a virtual machine and be able to get information like when memory is getting used. Same with disks, like the read and write late, and the read latency and write latency. All this stuff is also able to be seen. So it'll see it from the kernel point of view and the physical device command. Network stuff, we can get network intensive VM data. We may not be able to see exactly what packet is coming out because ESXi doesn't work like Wireshark, but we are able to see which VM is using up a lot of bandwidth. Alarms. Great for condition and events. Because we're not going to look at the dashboard all day and night. We're not going to look at these charts every single minute of our work. We can make VMware tell us when there is something that we need to look into. So you can create your alarms, you define them, you set what trigger will do what, and then what action it will take. So for example, it could do things if a snapshot is above 2 gigabytes or a host is using 90% of its memory, it can monitor for these things and let you know. So here we have, for example, a virtual machine using 75% of its CPU for 5 minutes. For more than 5 minutes, that'll trigger a warning. But if it's 90% for 5 minutes, it'll do a critical condition. If there's a heartbeat and it's intermittent, that'll cause a warning. If there's no heartbeat, a critical. We can create different triggers to occur for many events. And then the action. Will it email us? Will it do a pop-up? What will the alarm trigger in order to get our attention to respond? If you want to send an email, you have to provide the appropriate information. And always make sure to test to make sure that it does work. But just because you set up the email system doesn't necessarily mean it will work. You always have to verify. And then when you do get an alarm, you would go to the issue, you would right-click it and say acknowledge until you can fully resolve it. Then you would set reset to green. That way the alarm goes out, and if it happens again, a new trigger will arise. Any questions? Looking around, looks like no. Okie dokie. Just like always, keep at it in NetLab, and if you have any questions, please ask away in Discord.